Bernoulli differential equations is one method of reducing differential equations to linear differential equation. So a Bernoulli differential equation is of the form dy upon dx plus pxy is equals to qx y powered n. For a linear differential equation, the power of n here is equals to 1. But for a Bernoulli differential equation, the power is not equal to 1. So to solve a Bernoulli differential equation of the form, we will first get rid of the y power n term by dividing the whole equation by y power n, which would look like this. Next, we will substitute a value for y upon y power n. So y upon y power n is equal to z. So we will differentiate this equation, this substitution, in order to get the value of dy over dx. So this will become a term. Okay, so the first step for solving this type of differential equation is to remove the y power n term, and the second step would be to substitute a value. The second step would be to substitute a value for y over y powered n. So differentiating this substitution, we would get a value for dy upon dx, and then we will substitute it here. So the equation would look like this way. The whole equation would become in terms of z and x, where z is the dependent variable and x is the independent variable. Now this equation has become a linear differential equation, and thus to solve it we will find the integrating factor and then multiply it by the whole equation, and then multiply it by the whole equation. So the left hand side of the equation would become, the left hand side of the equation can be written in the form d upon dx z dot integrating factor, where z is the dependent variable. The next step would be to integrate both the left hand side and the right hand side with respect to x, and then we will put the value of z in the equation, and that would sort of solve our differential equation. Okay, let's do a question. So first we will remove the y power cube by dividing the whole equation by y power cubed. It will become like this. Let's call it equation 1. Now we will substitute a value for y powered minus 2. Let's suppose z as y is equals to y power minus 2. there. Then we will differentiate this equation and find the value of dy over dx. So here we have the value of dy upon dx, which we will put in our equation number 1 there. Then simplifying this equation would become, now for a linear equation, the coefficient of the differential should be positive 1. So let's multiply the whole equation by minus 2 over x. And this would be the final equation. So first let's find out the integrating factor. So the integrating factor would become 1 upon x squared. Next we will multiply the whole equation with the integrating factor. So it would kind of look like this. And as you have learned in linear differential equations, that the left hand side would become the differential of the dependent variable and the integrating factor. In this case it would look like this. So now we will integrate this equation on both sides with respect to x. It would look like this. Then simplifying it would make it like this. So like this. So integrating on both sides would become, the integral would look like this. Now we will put back the value of z in it. There, that's the solution of this differential equation. If we want to simplify it and make y the subject of this equation, if we want to make y the subject of this equation, it would look like this. So this is the solution of the Bernoulli differential equation. Thank you.